Assalamu alaikum. Today we discuss chemistry chapter 6 section 4 metallic bonding. Objectives of this section: describe how metallic bond is formed, explain why metals are good electrical and thermal conductors, explain why metal surfaces are shiny, explain why metals are malleable and ductile. Metallic bonding. Chemical bonding is different in metals than it is in ionic compounds or molecular compounds or covalent network compounds. As we discussed before, that the ionic bond is formed between positive ion and negative ion. An atom loses an electron or more, and another atom gains an electron or more, and the electrostatic attraction between them causes ionic bond, like in potassium chloride. So in potassium chloride, positive potassium ion and negative chloride ion are bound together with ionic bond. The covalent bond, two atoms share atoms with each other, like chlorine. Two chlorine atoms share electrons with each other, so they form covalent bond. While in metallic bonds, here the atoms and the electrons exist around them, like in potassium. Potassium is a metal, so the bond between its atom is metallic bond. How metallic bond take place? As you can see here, the metal atoms, they are positive charged because the electrons are removed, the valence electrons, and the electrons are free to move throughout the whole crystal. The electrons do not belong to any atom. They roam through the crystal. So the metallic bond model: in a metal, the vacant orbitals in the atom's outer energy levels overlap. The orbitals, the vacant, the empty orbitals of each atom overlap with other atoms, form a band. This overlapping of orbitals allows the outer electrons of the atom to roam freely throughout the entire metal, not belong to a specific atom. The electrons are delocalized, which means that they do not belong to any one atom, but move freely about the metal network of empty atomic orbitals. They move through the whole crystal, the entire crystal. The moving electrons or mobile electrons form a sea of electrons around the metal atoms, which are packed together in a crystal lattice. As you can see here the atoms and here the electrons. The electrons in the second figure move around, so they form sea of electrons. They do not exist in a specific place. They move throughout the crystal, so they form sea of electrons. So the metallic bonding is the chemical bonding that results from the attraction between metal atoms and the surrounding sea of electrons. Here the atoms are positive because the electrons are removed, and the electrons move within the crystal, so there is attraction between the metals, the atoms which are positive, and the sea of electron which is negative, so they form metallic bond. So metallic bonding, the chemical bonding that results from the attraction between metal atoms and the surrounding sea of electrons. The properties of metals. What are the properties of metals? The unique properties or characteristics of metals gives metals their characteristic properties. So the metallic bonding gives metals their characteristic properties. What are the properties of metals? Number one, metals have high electrical conductivity. They are good conductors of electricity. Metals have high thermal conductivity, good conductors of heat. They are shiny, or they have shiny appearance, or they have metallic luster. They are malleable, they have malleability and ductility. So these are the characteristics of metals. Why metals have high electrical and thermal conductivity? Because the free electrons can move in the network of metal atoms. So these free electrons, localized electrons, delocalized electrons, are not fixed. They move through the crystal. As they can move through the crystal, they are responsible for the electrical and thermal conductivity. So metals have high electrical and thermal conductivity due to the freedom of electrons to move in a network of metal atoms. Metals have metallic shiny appearance or metallic luster. As you can see here in the figure, gold is a metal and it's shiny. Why it's shiny? Shiny means it reflects light. So light here, it absorbs light from the sun, absorbs light in general, and then re-emit it again. So because they contain many orbitals separated by small energy differences. The energy difference between orbitals is small. So they can absorb a wide range of light frequencies. When light falls on them, they absorb light. And then re-emit light at the same frequency. After absorbing light, they emit light again, so they appear to be shiny. Malleability. What's meant by malleability? Or metals are malleable. Metals are malleable, as you can see in the figure. You can hammer a piece of metal to become a thin sheet. So, to convert a metal into a thin sheet, so it has the malleability, ability of a substance to be hammered or beaten into thin sheets. So, to hammer a piece of metal and form thin sheet is called malleability. As iron, as gold, silver, so they can be shaped easily. This is malleability. So malleability, ability of substance to be hammered or beaten into thin sheets. Ductility. We can make wires of copper, wires of aluminum, wires of iron. So to make wires is called ductility. So as you can see here, we can make wires of copper, thin wires of copper. So the ability of a substance to be drawn or pulled to form wires or extruded through a small opening to produce a wire is called ductility. So to pull a metal to form wires is called ductility. So metals can form wires because they are ductile. Why metals are malleable and ductile? Metals are malleable and ductile because metallic bonding is the same in all directions throughout the solid. So when struck, one plane of atoms in a metal can slide past another one without resistance or breaking bonds. So no bonds are broken. As you can see here in the figure, the first one, the left one, here a force exerted on the first plane, so the first plane moves to right as appears in the right figure. So this is a plane of atoms. This plane of atoms can move because no bonds are broken. the bonds are the same in all directions. So when a force acting on a metal, so it starts to move, the plane of atoms start to move, so they are malleable and ductile. Metallic bond strength. The bond in iron is the same as the bond in copper? No, they are different. So metallic bond strength varies with, depends on what? Number one, the nuclear charge of the metal atoms, the atomic number or the number of protons, the nuclear charge. As the nuclear charge increases, the metallic bond increases. And number of electrons in the metal's electron sea. As the number of electrons increases, the metallic bond strength increases also. So metallic bond strength depends on the nuclear charge or atomic number or number of protons and the number of electrons in the metal's electron sea. The amount of energy as heat required to vaporize a metal is a measure of the strength of the bonds. Some metals need a large amount of energy to vaporize or to melt because the metallic bond strength is strong. So the stronger the metallic bond strength, the more energy is required to vaporize or melt. The energy required to vaporize a metal is called enthalpy of vaporization. The amount of energy absorbed as heat when an amount of a substance vaporized at constant pressure is called enthalpy of vaporization. The amount of energy absorbed as heat, so heat is needed when a specific amount of a substance vaporized at constant pressure. This is the last point in our lesson. Thanks a lot.